Hello, I'm Ronald Hood from Montreal, Canada, and the topic of my little video tonight is AI planning for four-dimension trajectory planning in civil airspace. Well, that seems to be a mouthful, so let me decompose it into its major components. As some of you may know, commercial air traffic has expanded at a rate of about 4%, pretty much since the post after World War II. So this increase in commercial air traffic throughout the world has created havoc in a system that was designed in the 1950s and 60s using ground-based navigation, radio navigation aids that steered aircraft through that civil airspace from an origin to a destination. So as the traffic increased, some areas of the world, for example, the west coast of the United States of America and Western Europe, have had very much difficulty in catering to this increased demand for airspace and for routes going through that airspace. So civil aviation authorities, including Eurocontrol for the European territory with its CSAR program, and the Federal Aviation Administration in the United States of America with its NextGen program, have researched means of increasing the capacity of the airspace. And one of those methods they're investigating for the next 5 to 10 years is four-dimensional navigation. So what is four-dimensional navigation? Basically, 2D navigation consists of navigating on a map. So using latitudes and longitudes, and then navigating from one waypoint to the next that link your origin airport to your destination. Well, although that might be an interesting problem, it doesn't really reflect the complexity of flying in airspace. So it is necessary to add a third dimension, the vertical dimension, in order to properly characterize the flight of the aircraft as it is going from one point to another. So 3D navigation brings about some challenge of its own, in that to be able to do it effectively and efficiently, you have to be aware and cognizant of the aircraft performance characteristics. And only in recent years have flight management systems become powerful enough to be able to handle this third dimension. Well, as if that wasn't enough, now the air traffic management organizations would like to bring in a fourth dimension into the picture, which is time. So in order to increase the capacity and to increase the density of aircraft into airspace, what the authorities would like to do is to make the air traffic more predictable. So rather than have to plan for a very large window of arrival for aircraft, one through regional airspaces, and then finally at its destination, the authorities would like to make those passages from one zone to another, and ultimately the arrival at the aircraft, occur in a very definite time slot. So the advantage that this would have is if you are able in time to predict or demand that an aircraft arrive at a waypoint or arrive at the border between two airspace regions, then the traffic is more predictable. Then you can, if you can manage to do that, then you can increase the density into that airspace. So now, if I'm in an aircraft, that problem becomes very difficult, and this is where I was asked to look into AI planning techniques could help manage this four-dimensional problem. So typically in the aircraft, the crew will either be given a flight plan route to fly from their origin airport to a destination airport, and a path, a route to follow from those two destinations. Then typically, under this new program, the CSAR or the NextGen program in the United States of America, Then the pilot, in addition to be given those waypoints in three-dimensional space, they would be given time windows at which they have to cross specific points, typically the regions, the boundaries between air traffic control regions. And then ultimately, they also would put a window in time for the arrival at the destination airport to help airport authorities better plan the ground traffic of all of these incoming aircraft into their airport, and therefore increase the capacity, the handling capacity of the airplane and the runways. So now putting those four dimensions into the cockpit demands a very heavy workload on the part of the pilots. And then, as if again that wasn't enough, airlines today are very energy and fossil fuel conscious, so they want not only the pilot to be able to follow a flight plan route that was given to them, not only the air traffic controller would like them to be able to arrive within very specific time windows, now also the airline operations center would like them to do this with the least amount of fuel possible. So now, again, another dimension that's added to the flight. And I think AI planning techniques show some very interesting potential for helping the two aspects of this problem. First, the four-dimensional navigation problem. So how do I get, so the goal is getting the aircraft to a destination, following a flight route. So the waypoints can be considered being the states of our domain space, and then arrive at the end within a specific time window. And then once that is done, once I have managed to bring in this first problem of meeting all of my time targets into the three-dimensional airspace all the way to the end, then is how do I optimize? Because those windows are never given as fixed points in time. They are given as windows. So within those windows, how can I optimize my flight? And how can I fly? Can I fly faster? Can I fly higher or lower? Can I try to take advantage of the prevailing winds in order to minimize the amount of fuel I will be consuming? So again, as you can see, a fairly complex problem, a problem that cannot be solved without the use of, or without the help of digital computers. In some cases, the problem is significant enough that it would not typically be done with an airborne embedded computer system that you would typically find in a modern advanced flight management system. Some of it may be computed on the ground and then uplinked to the aircraft. And then the optimization may perhaps be doable within the confines and the capacity of embedded processor in the flight management system. So a very interesting problem to look at. I'm very interested in what I've learned so far in the AI planning course. This is, for me, is a little bit of a rediscovery of artificial intelligence. I've taken a number of classes in the mid-'80s. So obviously, I'm very interested in finding what has happened since the late 80s, early 90s up to this day. How have the AI planning techniques evolved? And then throughout the course, I will be looking at how these techniques and which techniques would be the most suitable to address the problem I've been mandated to handle. So looking forward to learn more on the course. It's been very interesting so far, and looking forward to the next lessons and the next 3 weeks in the course. I'm just completing, as you know, week number 2, and about to start week number 3. So looking forward to meet you on one of the forums, perhaps on Second Life, and wish you all good luck and interesting challenges to tackle with. So long from Quebec, Canada. À la prochaine!